Hello everyone. Just give me a second to toggle on live streaming today and thanks for joining. Just give me a second. Last time it was giving us some issues, so hopefully this time it does not. Okay, awesome. Hi everyone, thanks for joining. As we wait for more folks to join in, we'll still start the webinar. It's called Practical RAG Implementation with Efficient LLMs. So this is going to feature a lot of logos that you're currently seeing on the screen. And we have an amazing speaker who is an expert in the dev space. He's Pawan. He is a developer advocate here at SingleStore and is also responsible for uh, delivering anything that's related to like the latest trends in tech and AI to you all. And we recently did a meetup in Bangalore, I think last month, and we had an amazing turnout there. So if you guys are situated in Bangalore and the areas around, and if you want to go ahead and attend any such community events, feel free to connect with us on LinkedIn. I'm with my personal name, and Pavan is there as well. I'm Yukti. One of my main jobs here at SingleStore is to organize these weekly AI webinars that we bring to you guys. And uh, you might notice that you all are currently in a listen only mode. There is a Zoom Q&A button that is present at the bottom of your console. You can use that to interact with us in case you have any questions. Just note that I will be providing the resources to everything to you guys in the chat. So yeah, I'll just give it over to Pavan now. So please take it away, Pavan. Thank you.
Thanks, Yukti. Thanks for the introduction and everything. So let me do a slideshow, and I'm audible, and the screen, everything is visible, right?
Yeah, it's fine.
Okay, okay. Hey guys, let me minimize my screen here. Hey guys, welcome to this webinar on practical RAG implementation with efficient LLMs. So in this, I'm going to use SingleStore as a vector database in this while building this RAG system application. And I'm going to use LangChain to chain everything. Basically, LangChain, as you guys know, is a open source LLM framework, which is well known. And I'm going to use two famous LLMs, that is DeepSeek R1 and Llama 4 from Meta. So let's get started. So this is me, Pawan Belagati. I'm one of the top voices on LinkedIn, and I produce a lot of content on basically on Medium, LinkedIn, and recently started YouTube videos. So you can follow me on YouTube, LinkedIn, and Medium also. So I work at SingleStore as a technology evangelist, a developer advocate. And yeah, that's about me. And this is the table of contents. I'm going to talk about LLMs, techniques to improve LLMs. I'm going to talk about retrieval augmented generation. I'm going to talk about the RAG workflow, and then I'm going to talk about LangChain, and then DeepSeek R1, RAG with DeepSeek R1, and I'm going to talk about the next LLM, that is Llama 4, and then I'll show you the practical implementation of RAG with Llama 4, and at last I'm also going to talk about single store, why you guys need to use single store as the all-in-one database for all your application, whether you're building real-time applications or AI applications or RAG applications. So let's get started with understanding LLMs. So this is the first slides about LLMs, large language models. What exactly these are made up of? The data, structured, unstructured data, anything that you find on the internet, Wikipedia pages, YouTube videos, anything structured, unstructured data, and then architecture, right? The transformer architecture, what we call, and then some kind of training, like with human feedback, with human supervised, unsupervised. So with the data and architecture plus training, that's how LLMs are made up of. But LLMs have some kind of limitations, right? So when it comes to building chatbots or AI applications only with LLMs, there are some limitations. So what are those limitations? The knowledge cutoff date. All these LLMs have a knowledge cutoff date. So if you ask them something recent, they don't usually give you the responses. They will give now, since they have all the ability to uh, do tool calling, go search the web, but they can't usually sometimes verify their own responses, and they still hallucinate, right? They come up with their own made up answers, responses, and also, and the other thing is they don't have access to the proprietary data, custom data. Think that you are in a healthcare company startup and you want to build custom chatbot application. LLMs, if you just use LLMs, right, the open source or closed source, if you like, there'll be little security issues, and also they don't have the access to your proprietary data, right? When if you want to build custom chatbot applications, and then also there is a context limitation with all these LLMs. So these are some of the main limitations if you just use LLMs, right? So what are the techniques to improve LLMs, right? So one is prompt engineering, which is nothing but the art and science of refining your prompts, right? And seeing the output and making sure what type of prompts to use. And then that's a very easy one, the prompt engineering. And then the fine tuning is where you use a base model and then you fine tune it using your custom data so that it understands your vocabulary and all that when you're building custom um, chatbot or AI applications. And then comes the RAG one, which is RAG Retrieval Augmented Generation, which is the recommended approach to improve LLM applications. With RAG, you can actually have access to real-time data, your custom data, and it is also cost effective and easily you can update the knowledge there using a vector database. And fine tuning is okay, but it requires a lot of computing power and all. So that's why compared to prompt engineering, fine tuning, and RAG is mostly recommended approach to improve LLM applications. So actually your LLM, what exactly it needs is an expert knowledge. So that's how RAG comes into the picture and is considered one of the best approaches when building AI or RAG applications, and even to reduce LLM hallucinating behavior. So as you can see, right, the LLM, you enter a query, it goes through the language model, anything, right? Any language model, and you will get a response. So there is no way you can verify that response, like is it correct, is it not correct, right? But with RAG, you can attach your custom documents using a vector database. And when you ask a query, it will go through that vector database to fetch the relevant chunks. And it goes through. Now you have the augmented query and then the relevant chunk. It goes through the language model to give you the proper contextually relevant response back, right? So that is where RAG plays really well compared to just using LLMs in your chatbot applications or LLM powered applications. So this is about retrieval augmented generation. There are simple steps in this, like document processing, query processing, and then the response generation. So like I said, right, LLMs usually hallucinate. They come up with their own answers, they made up answers, and there is no way to actually verify these responses. And RAG is the approach of enhancing LLMs with external custom data, custom knowledge, so that they don't hallucinate and generate inaccurate responses. So with RAG, you will get contextually relevant responses since you are attaching a custom data, right? The query also gets converted into a vector embedding. It goes through the, as you can see, right, in the first phase, the document processing. You have a document, custom document, which gets chunked, and each chunk gets converted into an embedding, right? And then all these embeddings are stored in a vector store like SingleStore. And when a user query comes in, even that query gets converted into a vector embedding. And through vector similarity search, it goes through the vector store to find the matching chunk, and like top three matching chunk. And now that you have augmented query, the relevant chunk, at the end it goes through an LLM model to finally formulate the answer, contextually relevant answer back to the user. So RAG basically connects your AI applications and systems with external knowledge sources so that accurate and contextually relevant responses can be generated, right? So let's look at an example, right? I think last time also I used the same example. Without RAG, if you use just pre-trained LLMs with knowledge cutoff date, they usually hallucinate. If you ask a query like what treatment options for this patient with stage 2 NSCLC, um, if you're building a chatbot application and using just pre-trained LLMs, the response will be kind of outdated, right? Based on my training, standard options include surgery, chemotherapy, blah, blah, blah. But lot more research might have been already done, which the pre-trained LLMs usually can't, since they don't access the real-time data, they usually fail there. But with RAG, you can attach all this custom research data using a vector database. And if you ask the same query, right, what treatment option for this patient with stage 2 NSCLC, since now with RAG, you have like attached custom research documents and all those things, everything is present. The response will be much better and contextually relevant, which is very useful for you to come to a conclusion what exactly needs to be used, right? As you can see the answer, right? The response with RAG based on 2025 NCCN guidelines and recent trial keynote 671 consider immunotherapy with blah blah blah. So that's how you can basically generate contextually relevant responses using RAG. And next, since in our tutorial I'm using LangChain, let's understand LangChain. LangChain is basically an open source LLM framework to help you build LLM powered applications. All right, so these are some of the modules or components you can call that LangChain has. It has LLMs. It's LLM agnostic. You can use open source or closed source LLMs, and there are indexes, document loaders, text splitters, and good integration with all the vector stores and retrievers. And then there are agents. You can leverage LLMs for reasoning to automate decision making. You can basically build agentic applications using LangChain. And there is a memory component that maintains conversational history if you're building chat applications, right? And you can also have long-term, short-term memory and all that, and also chains. That's one of the main component of LangChain, where it usually combine LLMs with modules to execute a sequence of functions so that you can build workflows using LangChain. And also there are prompt templates. You can use already existing prompt templates, or you can build your own custom prompt templates in LangChain, right? If you're building a AI application, and if you can build a prompt template like hey, answer everything, respond everything as if I'm a 5-year-old. So you can, that way you can actually build prompt templates. You can make sure you can actually customize everything. And you can also tell the prompt saying, hey, you act as an AI expert and explain this query with a proper response. And then the whole application starts acting as if it's a AI expert. So using all these components, you can actually chain everything and actually build very robust RAG and AI applications. What all you can build, like I said, right? The LLM, memory, prompt, agents, all these components, you can chain everything, and finally you can actually build question answering over docs, summarization, chatbots, querying tabular data, interacting with APIs, code understanding. So you can build a lot of such projects using LangChain. And yeah, I mean, um, one uh, the famous model that recently came up, that is DeepSeek R1, made a huge noise in the AI industry because of the reason that when compared to OpenAI, it used a very less cost. And like you can see, right, the model sparked widespread discussion due to its unprecedented cost efficiency compared to OpenAI's O1 model. and 90 to 95% lower inference costs compared to OpenAI's model. So that made everyone use DeepSeek R1 in their AI applications, and even I used. I'm going to show you in this tutorial, in the tutorial next. So DeepSeek R1 was introduced by a Chinese artificial intelligence startup, that is DeepSeek, and which is really good in reasoning and math and coding. So we're going to see that. And this is a simple tutorial, RAG with LangChain, DeepSeek R1, and SingleStore. So as you can see, we have a document. The document gets split, and we'll generate text embeddings, and we'll store all those embeddings in a vector store like SingleStore. And when I use a query, like I'll only ask a query, and even the query gets converted into a vector embedding, and it goes through the vector store, that is SingleStore, and to find the using similarity search, and it finds the relevant chunks. And at the end, it will go through our DeepSeek R1 model to finally respond back uh, to the query that we asked. So, like I said, DeepSeek R1 is our LLM model here, and LangChain as our LLM framework to bind everything together. And we are using SingleStore as a vector database here. Okay. And yeah, let me show you this. And for this, you need to have create SingleStore account. And if you want, I can share you this. Um, okay, I think host and panel is something. I don't know. I think you can share this link, right?
Yeah, sure.
Yeah. So after that, um, you can go to SingleStore and sign up. SingleStore has a free share tier. You can use it for free. You will get some free credits once you sign up for the first time. And actually, that time I did not get DeepSeek R1 API key suddenly. So what I did, I went to NVIDIA NIM, which is inference microservices from NVIDIA. So um, that's where I actually got the DeepSeek R1 API key, right? So that's how I got it. As you can see, you can go to models, and here you can actually find the DeepSeek R1 key. Okay, so let me go to the particular. So once you sign up and sign into SingleStore, you this is where you will land basically, and you need to have create a workspace for yourself, and then create a database for yourself. And once you create a workspace and database, one interesting thing about SingleStore is SingleStore has integrated you know notebook feature, which is really cool. You can go to Data Studio and then create a new notebook for yourself, give it a name, and just create it. And I have already created my notebook code. Everything is already here. I'm just going to explain. So before running your code, you need to make sure you add your workspace, and then uh, your database there. Right. So let's start step by step, like RAG system with DeepSeek R1, LangChain, and SingleStore. So, like I said, we will set the DeepSeek API key from NVIDIA NIM microservice, and you can go to NVIDIA NIM microservice and actually get the um, API key. And after that, uh, the install the required libraries. That's what I'm doing. I'm gonna install LangChain and SingleStore DB, and official LangChain DeepSeek official library, and then import the libraries. Since I'm using PDF here, this is a PDF, publicly available PDF that I'm using, and I'm loading my custom document, that is the PDF. And next is I'm splitting that document into chunks. And after that, I'm creating embeddings for my for these chunks, right? Using OpenAI. And here is what I'm adding OpenAI key. And once we create the embeddings, we need to store these embeddings in our vector store. So that's where I'm storing these embeddings. And for that, I'm creating a table under DeepSeek database. I'm creating a table named DeepSeek RAG. And this is the host admin password and the host URL and your database name. You can get them easily from your single store account, and port is as usual 3306. And let's initialize the DeepSeek through NVIDIA NIM. And like I said, um, this is the API key you need to add. You get from NVIDIA NIM microservice. And then we are just adding some parameters like temperature, top, P, and maximum tokens. And then let's create a RAG chain using LangChain. And if you ask a query, right, what's India's GDP growth is projected to be? Because our PDF file basically it's about some government knowledge that's present. So if you ask a query like what's India's GDP growth is projected to be, you can see the results saying these are this is the response that you're gonna get. But right? Yeah, I mean, this is the complete answer that you are getting from you by using R1, DeepSeek R1 in our RAG system, right? India's GDP growth. So it starts like this. Like, okay, so the user is asking about India's projected GDP growth. Let me look through the provided context to find the relevant information. As you can see, it is finding the answer through the provided context, right? We have provided that PDF file. From there, it is actually fetching the answers. So India's GDP growth rate is projected to moderate to 5.8% in 2023, down from blah, blah, blah. It will also give you the sources and where it is present and all that. So that's how you can basically build simple or robust RAG applications using DeepSeek R1, LangChain, and SingleStore. And yeah, I mean, I'm going to share that GitHub repo with you all. And now let's talk about Meta's Llama 4 model, which also made a big noise because it's a family of open source multi-model LLMs that's designed for efficiency and accessibility. The models are available basically in three different sizes. One is Llama 4 Scout, Llama 4 Maverick, and Llama 4 Behemoth with different parameters. And today in our tutorial, we're going to use Llama 4 Maverick and see how the responses will be if we are building a RAG application, right? So this is a simple setup. Like I said, we are using Llama 4 as our LLM model, LangChain as our LLM framework to bind everything together again, and SingleStore as a vector database. So we have a document which gets split into chunks and embeddings are created. All these embeddings are stored in a vector store like SingleStore, and then when a user query comes in, it goes through the vector store using similarity search, semantic search, and at the end it goes through the LLM model that is Llama 4 to uh, give us final contextually relevant answer back. So let's go to the GitHub, the tutorial code. Um, so in this, I'm using again OpenRouter to get the Llama 4 API key, just like how I used NVIDIA NIM microservice to get the DeepSeek R1 API key. I'm using here OpenRouter. OpenRouter provides all the API keys for famous LLM models. So this is the complete notebook code of RAG setup using Llama 4 Maverick and LangChain. Similarly, installing the first step is to install and import the required libraries and dependencies. I'm installing LangChain, LangChain community, SingleStore DB, and then I'm also setting up my OpenAI API key, and I'm loading the PDF document. Here I'm loading this custom publicly available PDF file and then splitting the document into chunks. And after that, we create embeddings, and embeddings are stored in vector store, right? And we have a table name here, and this is the host from SingleStore, port name, user, password, and database. And we'll initialize the Llama 4 model via OpenRouter. OpenRouter, if you go to OpenRouter, you can easily get the all the actually DeepSeek Carbon API key also you can get it from here only. So you can go from here, Llama 4, right? Meta Llama 4. You can basically get the API key from here, right? Create API key. So that's how you can get the API key, add your API key, and mention your model name, adjust some parameters, and then create a retrieval QA chain using LangChain. And then let's ask a query, right? What environmental trends in India are highlighted in the NVStats India 2024 report? So this document contains all the answers for that, and that's how it will respond, right? The NVStats India 2024 report highlights the following environmental trends and concerns in India. Concerns about rapidly depleting vital resources, blah, blah, blah. And similarly, I asked some different questions and then it responded back really well. I mean, I just checked and the response, um, all the responses were contextually relevant and highly accurate, right? So that's it about how you can basically build RAG with Meta's Llama 4 and SingleStore. And let's move on and talk about, yeah, so this is a typical enterprise, the data architecture. So when usually companies feel like when they start off, um, um, they feel like their customers are running a lot of analytical workloads and they feel like having OLAP database. And certain point, they feel like there are other customers who are demanding and they're running a lot of transactional workloads and they need to have a OLTP database. And now all the hype is about Gen AI, generative AI applications. And now they feel like having a separate vector database, right? So if you see the whole architecture using different databases at different levels, it's a kind of a mess for your data folks to handle all this and the data going in and going out and indexing all those things. So what we suggest is like, having single store as an all-in-one data platform, because single store supports all types of data. Single store started supporting vector storage long back in 2017 itself, and single store supports hybrid search and semantic search, and it will do much more than just what your specialized vector database does, and it will help you with re-ranking and all those things. So you can basically remove all your unwanted databases and use just all-in-one database like a single store. And this is how single store works for AI. And you can actually go to this particular link where we have a complete uh, web page for how you can basically use single store to build your Gen AI applications. We have a good integration with all the frameworks like Llama Index, LangChain, right? And we have, like I showed, right? We have a notebook container. You can create your own notebooks and build your AI applications. And like I said, at the end, you can see single source supports all types of data, rows and column data, vectors and JSON documents, geospatial key value, and all those things. So that's how you can basically use single store to build your AI applications. And yeah, I just created this very simple uh, presentation. And thanks, guys. Let me know if you have any questions, and I'll be happy to answer them.
All right. So, Pawan, there are some questions. So, there's a question from Nitish. They are saying that can it deal with multi-hop RAG? And one more note that can you please provide the link to your notebook in the chat?
I can share this, right?
Yeah. The question, I can repeat the question for you. They say that, hi Pawan, can it deal with multi-hop RAG, HOP?
Yeah. Multi-hop RAG. Yes. You can deal with a multi-hop RAG. And can you send the link to the notebook, please? Yeah. Are you sending these links to the, or should I send it here?
I mean, you can send it either on Slack, either on Zoom, like
Okay.
whatever you prefer, and I can just
Sure.
send it forward to
Uh,
everyone.
sure. I'm just sending it to you here. Yeah, I shared it with the host and panelists
Yeah,
there.
by default, that's what happens. It's all right. I'll just give
Okay.
me a sec.
I just lost the Q&A thing. Yeah. Can you use a GraphDB and use SingleStore as the backend? Yeah, you can. Actually, SingleStore can also be used as a GraphDB. I mean, Graph DB is where knowledge graph, you can create relationship between the content and you can basically create all that inside single store database and actually run queries and actually build a perfect RAG application. I think we have a we have also done a webinar by one of our engineers where he will show how you can actually use single store as a graph DB and build knowledge graphs and basically query and get the contextually relevant responses. You can actually use single store as a graph DB also. Yes. I needed native graph database. Hence, yeah, I mean, you can, like I said, single store supports all types of data. You can use single store as for your backend, and then you can use the other databases also. But what I suggest is instead of using different databases, you can use single store for your uh, as a graph DB also. Right? Yeah, yeah. She will share that like a Git repo. She will share.
I
Okay.
have put that in
Yeah,
the chat as well. Just give me a
yeah,
second.
yeah.
Yeah.
Let me also share the other one. There are two actually. So this is about the DeepSeek R1. Yeah, I got some stars also there, 26 stars, and yeah, this one went really well. I mean,
Yeah.
I wrote an article also on dev.to and it went really well. No, yeah, I'm sharing that here. No. Can I use single store vector DB as a MCP server? Yes, of course. Uh, we have the single store MCP server. You can go to single store MCP server. We have a full repo and that you can presenting. There is a blog also, and you can basically go to this single store MCP server and you can actually use Claude as your uh, and you can use Claude and talk to it in natural language and create. You can tell it to create a notebook for you, create a database for you, and yeah, I'm going to share that link also so that they can share. Yep. How single store compared to Pinecone or other vector DB? Like I said, right? Pinecone just supports, I think, vector storage, and it will help you with hybrid search, and all those things. It's good for only GenA applications. But what if on top of GenA applications, you want to do real-time analytics? At that time, something like Pinecone fails. So that's where people use single store as an all-in-one database. Since single store supports all types of data, so you will have a lot of flexibility when it comes to using different types of data. So since single store supports all types of data, so Pinecone, Milvus, and all these things are just they are specialized vector databases. They are known for just doing a vector database thing. Can we create a pipeline for change data coming into a single store to create embeddings and store them into single store? Yes, you can create that change data capture from any other source, and you can create embeddings and store them in vector DB. I mean, in single store as a vector DB. Yes, you can do that. Yes. Where does embedding creation workloads run? I didn't get your question. Where does embedding creation workloads run? I mean, on the, like I said, right? In the notebook only they run, and that embedding creation happens and all these embeddings are stored. Then we'll push all these embeddings into our vector store. So if you want to see how the uh, it is stored, let me go to deployments and go to one of the databases. That was DeepSeek, right? Yeah. Let's see how the data is shared at DeepSeek RAG. And if you go to sample data and see how it is stored, the data, right? The ID, content, this is the content, and this is how the vector type embeddings are created, and metadata is also there. So this is how a sample data is. We pushed that PDF file, right? So this is how it is stored, and then this will help the system to understand and fetch the relevant chunks, matching chunks when you're creating EI or RAG applications. A single store, its own embedding and chunk models. No, single store doesn't have its own embedding and chunking models yet, or I need to use open source. Yeah, you can use open source, but single store doesn't have embedding or chunking models. It'll help you in storage and doing hybrid search and all those things. And if you're creating on top of your AI, Gen AI applications, if you want to do real-time analytics and all those things, that will help you. I mean, CDC from single store MySQL. Yes, you can do that. Yes, I mean CDC from single store MySQL and MySQL and Kai. Yes, yes, we have a. If you're using MongoDB, on top of that, so MongoDB basically doesn't help you with real-time analytics, right? So that is where single store will really help you. If you're already using MongoDB, on top of that, we have something called Kai. So you can use that and basically build your real-time analytical applications using single store. So we have this single store Kai. So this is where you can basically run the compatible you can mention your Mongo URI, and on top of that, you can run the queries, which is compatible with both MongoDB and single store. Yep. Can single store be used in a containerized format in a embedding device, like in a cell-side gateway, or to run small custom LLMs? Oh my God, this is little. I don't know this. Can single store be used in a containerized format? Like you're talking about do we have a Docker this thing? If I'm not wrong, we have a Docker. You can run it using Docker, and on your local, you can try it out, build RAG applications that we have. If you're asking that to me, like containerized format, yes, we have a single store Docker support, and you can run that as an image. Let's see if I have financial numbers, do some mathematical operations. I should be using RAG or any other similar to VectorDB to get analytics like sum, average. Let's if I have financial numbers to some mathematical operations. Yeah, I mean, if your documents have that numbers, you can, there is something called multimodal models. You can also use multimodal models that understand different types of data in your RAG applications. That way they understand both the numbers, the images, the audio, video, and all those things. So you can use that. And yeah, you can basically do that also. How much memory storage and CPU do you need? And you need to check, go to single store and then go to the pricing page. But we have pre-shared tier. I think you'll get once you sign up $600, so you can use it until you finish your this thing. But I'm not very sure about the memory storage and CPU usage. Sorry. Sure, guys, we can connect on LinkedIn also. I'm very active on LinkedIn. I usually keep creating content on AI, Gen AI. So yeah, I'm
Seems like if we don't
active.
have any other questions, Pawan, is it okay that
Yeah,
if we can end the session earlier?
yeah. Sure, sure,
So
sure.
for everyone that has attended or if anyone that has joined a bit late, we will be rolling out the emails that will have the recording and all the resources that are required for you to get started ASAP. Everything will be there in the email. You will be getting it shortly. And Pawan, just make sure to share everything that's relevant. If you want to
Sure,
add
sure,
any that's relevant to the session, I can also include that so that people don't have to go and watch the entire recording. So,
sure.
yeah, we are all obviously Pawan also mentioned we are all available on LinkedIn. So if you have any feedback, any questions regarding any session, or if you have any ideas that you might want to see Single Store do, so let us know. You like our inbox is open, and yeah, that's it for today. Thanks for joining, and have a great rest of the day. Thank you, everyone. Bye.
Thanks, guys. Thanks. Bye bye.